Hello, year 8. So here we are. I'm just doing a little bit of kitchen science again. This is all about conduction and heat transfer. Our aim, the investigation, is to find out which material can conduct heat the fastest, and we're going to use ice cubes to help us work out which material transfers the heat from it into the ice cube to melt the ice cube the fastest. So I wanted to test a few different materials. I was most interested in this aluminium pan, comparing it with my stainless steel pan. I don't have any copper pans in the house, but maybe one of you guys could do that and test that. I've also got some ceramics. I've got a metal bowl actually covered in enamel. I wanted to see how that worked as well. And the table I'm on is wood, so I've got 5 materials. I could test any number. Here's my ice cubes ready. So my independent variable is the materials, right? That's what I'm testing, that's what I'm changing. I'm going to measure the time it takes for the ice cube to melt. So that's my dependent variable, isn't it? This is one of my controls, isn't it? Because all the ice cubes in here are the same size, the same volume of water in each one. Not exact, but I wonder if you can think of any ways that we can make that control variable much more accurate. Anyway, the other control variable is the room I'm in. Yeah, I'm tested them all in the same area. Okay, I'll put my ice cubes in. 3, 4. I'm going to put 1 on the table as well. So there's my 5. I'm going to start my stopwatch. Here it is. Stopwatch started. Okay. This might take a bit longer than a few minutes for the video, so I'm going to pause it here and then we'll come back to it and see what's actually happened. Okay, just coming back. It's been about 3 minutes so far. I'll show you what's happened so far. So here's my steel pan, actually looking like it's not melted that much at all. Here's my aluminium pan, that's melting pretty quickly actually. Ceramics, not that much. Steel metal covered in enamel, that's not really melting at all. And the one on the wooden table, again, not much melting, not much heat transfer. Okay, so I'll pause this. Something I've learnt from this, maybe we should be using quite small ice cubes, otherwise it's going to take a long time. Right, back again. 5 minutes 20 seconds. I'm recording that. The aluminium pan, the cube has completely melted. Right, so I'm going to record that. That's my dependent variable. I'm measuring 5 minutes 20 seconds for this kind of material. Now, the others, if you look at the steel pan, cube is still there. What I could do now is do another repeat for this aluminium pan. What I would probably do is bring it back up to room temperature first to make it a fair test, so it starts at the same temperature. So I put it under the tap, give it a rinse out with room temperature water, make sure it's back to the same temperature we started at, and then put another cube in. But once I've done that, right, I mean, it's pretty clear looking at all the other cubes. I mean, the wooden one, you can see here, that one in the ceramics, that one in there. The aluminium pan has outperformed all of them really by quite some way. So if I was going to do some cooking and I wanted to be really efficient with the heat transfer so that the heat from the burning gas got to the food as quickly as possible, I would use this aluminium pan. Okay, rather than the steel. It does work, it's a good conductor, but it's nowhere near as good as this one. So this is my favourite, I reckon. Okay, what we're going to do next then is look at actually in metals what is it about some metals that make them really good conductors? It's not just that the particles are very close together. There are some other properties within the metal that make them really good at transferring heat. And this is what we call free electrons within the structure of the metal. So it's not just the particles in the metal that are vibrating and passing on that heat energy. There's free electrons within the structure of the metal that also whiz around, bump into the next particle to pass on that heat. And some metals have many more free electrons than other metals. Okay, I'll post a video for that next. Right, carry on with the practical, get recording, and then we'll start making conclusions.